This video is all about solving radical inequalities in one variable. So when we solved inequalities in the past, we've used this technique called the number line technique. And if you think about it, when I draw a number line, there are an infinite number of numbers on that number line. And some of those numbers work in the inequality that I'm given, and some of the numbers don't. So what I'm doing in this process is basically taking that number line and mapping it out so I can tell which numbers work and which numbers don't. So the way I'm going to do that is I'm looking for things that are less than 11. So first thing I'm going to do is rule out anything that wouldn't work in the inequality in the first place, meaning I've got a square root here. And when you have square roots, if you have a negative number under the square root, then you get imaginary numbers. And there's no way to compare imaginary numbers and real numbers, so they don't even make sense when you have an inequality. So the first thing I'm going to do is I'm going to look under the radical, and I'm going to find the domain of this thing. So x minus 4, which is the radicand, has to be greater than or equal to 0. So that means that x has to be greater than or equal to 4. So immediately, I'm going to go to my number line. I'm going to put the number 4 on there. And then anything that is not greater than or equal to 4, which would give me back imaginary stuff, I'm going to go ahead and mark out. It's totally irrelevant for the problem. I won't be able to do anything with it. So I'm marking out the stuff that's less than 4 because my domain has to be greater than or equal to 4. Cool. So now what I'm going to do is take that stuff that's greater than 4, and I'm going to try to map out the stuff that works and doesn't work. So the way I'm going to do that is I'm going to look at this inequality, but instead of finding where it's less than, I'm going to find where it equals to, because the places where it equals 11 are going to be the places where it switches from working to not working. So I'm going to solve this as an equation like you did before. And we're isolating the radical, and then we square both sides because this is a square root, and then we add, and we get 13. So that number is going to go on the number line right here. Now, we now have two regions. One of these is less than 13 and greater than 4, and the other is greater than 13. So what I'm going to do now is test numbers in the inequality to see if they work or not. So from the region between 4 and 13, maybe I'll try to pick something convenient. How about, I don't know. Well, that doesn't have to be convenient. Let me test, say, 6. If I test 6 in this, 5 would be nice. Let's test 5. So if I test 5, I get 2 times the square root of 1, which is 1, plus 5 is less than 11. So that says that 7 is less than 11. And that's true. So this region here will work. If I test something bigger than 13, let's say 20, that would give me this. That would give me 2 times the square root of 16, which is 4, plus 5 is less than 11. So that says that 13 is less than 11, and that is not true. So my answer is this region. So I'm going to write that answer. So x has to fall between 4 and 13. X can be 4, because if I plug 4 in here, it gives me like 2 times 0 plus 5, which is less than 11. But it can't be equal to 13, because if I plug 13 in here, that would give me 11, and 11 is not less than 11. So that would be the answer to this one. Now, this process works exactly the same way, even when the inequality is more complicated. And the process, again, just to remind you, is get the domain, put it on a number line, solve it as if it's an equation, put those solutions on the number line, test intervals to see which intervals work, and then write your answer. Here's a more complicated example. I'm going to start by getting the domain. So here we have 2 radicals. So basically both of these have to give me real numbers for this to make any sense. So I want this to be x plus 3 is greater than or equal to 0, and x minus 2 is greater than or equal to 0. So that would mean that x has to be greater than negative 3, and x has to be greater than 2. So let me draw my number line. Now, I'm going to put negative 3 on there, We know x has to be greater than or equal to -3, so the stuff that's less than doesn't work. And I'm going to put 2 on there. And we know that x has to be greater than or equal to 2, so I know the stuff that's less than that also doesn't work. Remember, the numbers that are between -3 and 2 would give you a real number in one radical, but not in the other, so it's still imaginary, and you can't compare that to the number 5. All right, so now I'm going to take that inequality and solve it as if it's an equation. And we've done this before, so it'll be good to just sort of see it. That's an equal sign, by the way. I'm going to square both sides, but when I square that right-hand side, there's a subtraction in there, so I'm going to have to FOIL that out, or use the pattern of a perfect square trinomial. So I'm going to combine like terms. I'm going to isolate the remaining radical. My handwriting is getting messier and messier as I go along, and I apologize for that. Almost done with this step. And now I'm going to square both sides to get rid of the square root, and then add 2 to both sides. So I get 6, place that on the number line. Notice I'm not even trying to make my number line to scale, doesn't matter. So now I have 2 intervals I can try. Let me pick a number between 2 and 6. How about 4? So if I do that, I get 4 plus 3 is the square root of 7. 4 minus 2. 3 would have been easier, wouldn't it? Oh well. And then you go to 5. So that's the square root of 7, the square root of 2, is greater than or equal to 5. Now you can pull your calculator out and try this. The square root of 7 is like 2.6-ish. Square root of 2 is like 1.4-ish. There's no way that's bigger than 5. So that doesn't work. So I'm going to pick something bigger than 6. And let's see if I can pick something actually nicer this time. How about 13? It'll work in 1. So that would give me the square root of 13 plus 3 plus the square root of 13 minus 2. It's greater than or equal to 5. Again, you can pull your calculator out and do this, but that's the square root of 16. That's just 4. This is the square root of 11, which is about 3 point something, greater than or equal to 5. 4 plus 3 point something is clearly going to be greater than or equal to 5. So that one works. So then we need to write our answer. X is greater than 6, and then we look and see, is 6 included? Well, when I plug 6 back in, 6 plus 3 is 9, square root of that is 3, 6 minus 2 is 4, square root of that is 2. You get 5. It is equal to was in the original inequality, so it is included. Again, find the domain, put it on a number line. Solve as if it's an equation, put that on the number line. Test numbers to see which intervals work, write your answer.